Hello everyone, welcome to our lesson on the Pythagoras Theorem. This is part one of our lessons. We're going to have part two. Part one, we just want to understand the theorem and also know what it says. And then part two, we're going to look at the application. Right, this theorem actually is named after the Greek philosopher Pythagoras. Pythagoras made important developments in mathematics, astronomy, and the theory of music. This theorem, the Pythagoras theorem, was used long back, maybe 1000 years earlier, but Pythagoras may have been the first person to prove it. So that's why it is called the Pythagoras theorem. Right, the Pythagoras theorem is used a lot in algebra, trigonometry, measurement, analytical geometry, and Euclidean geometry. So we really need to understand this theorem. If you look at the triangles, it is not in all triangles where we can apply the Pythagoras theorem. The Pythagoras theorem applies in right-angled triangles only. And then we want to know about this side called the hypotenuse, which is the side of a right angle triangle. Right, the hypotenuse is the side opposite the 90-degree angle, okay, of a right angle triangle. And also you can say it is the longest side. If you look at the right angle triangle, the hypotenuse is the longest side. So how do you see the hypotenuse? It is the longest side of a right angle triangle, and also it is the side opposite the right angle. Some people do this and say this is actually an arrow pointing at the hypotenuse. If you check here, this thing sort of forms an arrow there, which is pointing at what? At the hypotenuse. You see that? So the hypotenuse is the side opposite a 90-degree angle or the right angle of a right angle triangle. It is the longest side of a right angle triangle. We've just said that. Right. Now, what does the Pythagoras theorem say? What does it say? In a right angle triangle, not in any other triangle, in a right angle triangle, the square of the hypotenuse, is what? Is equal to the sum of the squares of the other two sides. In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So if you look at triangle ABC here, which side is the hypotenuse? It is B. So the square of B, meaning that B squared is equal to the sum of the squares of the other two sides. The sum of the squares. So we have C squared plus A squared. So B squared is equal to C squared plus A squared. It is equal to the sum of the squares of the other two sides. That's what the Pythagoras theorem says. Okay? Right. So the reason we write, you can write this and just write Pythagoras. That's the reason we write. Or theorem of Pythagoras. And then here you can also write this in terms of the sides. When the sides are named like AC, you see B there, you can use the small letter B or AC. So AC and B there is just one thing. AB there and C is just one thing. And then BC there and this A there is just one thing. So you can write it like this or like this. That's the Pythagoras theorem. And then what about the converse? The converse theorem of the Pythagoras theorem. If the square of the longest side in a triangle is equal to the sum of the squares of the other two sides, then what does it mean? If B squared is equal to C squared plus A squared, what does that mean? It means the triangle is right angled. We get a lot of questions in the exam that will say, prove that triangle ABC is a right angled triangle. You have to prove that the square of the longest side is equal to the sum of the squares of the other two sides. Once you prove that, then it is what? It is the triangle is a right angle triangle. Let's say I have a triangle like this. We are not told that, let me say P, Q, R. We're not told that angle Q there is a right angle. You see, the symbol for a right angle is not there. But we're given size. This is 5, this is 3, this is 4. If you check, PR squared is equal to 5 squared, which is equal to 25. And then PR, PQ squared plus QR squared is equal to 3 squared plus 4 squared, which is equal to 25. You see that? So now the square of the longest side, the square of the hypotenuse, is equal to the sum of the squares of the other two sides, meaning that triangle PQR is a right angle triangle. You see that? Then you can put the symbol there for a what? For the right angle, because we've proved that this is a right angle triangle. Okay, so you write therefore, let me write it underneath here. Say therefore, triangle PQR is right angled. I'm trying to squeeze here. I'm not sure it's going to be clear. Right, and then what reason do we write? And then you can say the converse Pythagoras is the reason. Converse Pythagoras or converse theorem of Pythagoras. Okay, converse Pythagoras. You see that? That's how we do it. So the first one says, the theorem says, right, in a right angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. And then the converse says, if the square of the longest side in a triangle is equal to the sum of the squares of the other two sides, then the triangle is right angled. You see that? Now, let's do a few questions. Just have two of them, then we'll be done. Right, in triangle ABC, angle B there is 90 degrees. So this is a right angle triangle. AB is 9 units and BC is 12 units. Determine the length of AC. You can try to do this before I show you. Just pause the video and try. Right, let's do this together now. So it means our hypotenuse. Which one is our hypotenuse here? Is it AC? Yes, it is AC because it is opposite the 90-degree angle there. So AC squared is equal to AB squared plus BC squared. And then we see you're writing the statement, where is it? Statement and reason. You see that we're writing statement and reason. Okay, and then now we can substitute. This is what we have here. And then what we do to get AC, what we do, we can simplify this. And then what we do to get AC, we square root both sides. We square root both sides. Then AC is equal to 15 units. The other thing you can do, there's no need to do all these steps. From here, you have AC squared is equal to 9 squared plus 12 squared, isn't it? Just square root here. AC is equal to square root of 9 squared plus 12 squared. You just put this in the calculator as it is. You're going to get your 15 units. Okay, you see that? You can just square, you don't need to do all these steps. Right, let's do the last question. In triangle PQR, angle P is 90 degrees, so this is a right angle triangle. PQR is 25 centimeters, and then PQ is 24 centimeters. Determine the length of PR. Let's try this. Right. A lot of people, when it comes to this question, they are tempted to change the Pythagoras theorem. The Pythagoras theorem does not change. It will never change. It says that the hypotenuse squared is equal to the sum of the squares of the other two sides. So that will never change. We are not looking for the hypotenuse here, we're looking for one of the sides. It does not mean that you have to change the Pythagoras theorem. So the Pythagoras theorem still stands and say RQ squared, in this case, RQ squared is equal to P squared plus PR squared. So I advise you to start with this. I know some people just do the first thing of just subtracting, saying PR squared is equal to QR squared minus what? PQ squared. It's okay, right? But now some people are tempted to change the Pythagoras theorem instead to say PR squared is equal to PQ squared plus QR squared. No, it's always the hypotenuse squared being equal to the sum of the squares of the other two sides. And then let's substitute what we have. Right, you see that? And then we just substitute. Okay, and then from here we can transpose or subtract 24 squared from both sides of the equation, and then we get 25 squared minus 24 squared is equal to PR squared. See that? Please don't change the Pythagoras theorem. Write it and substitute accordingly. And then we get 49 there. We square root both sides, and then we get our uh, 7 centimeters for PR. Like I said before, there's no need to do all these steps. From this step here, where is it? 25 squared is equal to 24 squared plus PR squared. Then 25 squared is minus 24 squared is equal to PR squared, isn't it? And then from here, just square root this. 25 squared minus 24 squared. This is squared, okay, is equal to PR. You see, you're going to get your 7 centimeters is equal to PR. Done. So this is how the Pythagoras theorem is. And then in the second part of our lesson, we're going to be looking at the application of this theorem. Let's meet in part 2 of Pythagoras theorem.